participar en este evento con todos vosotros. Today, we are going to discuss the hybrid smart contracts, what are they exactly, and the importance of decentralized Oracle networks. So, as I said in Spanish, my name is Andrej Rakic, and I'm a developer advocate for Chainlink protocol at Chainlink Labs. You can see here listed my Twitter handle, my email, but I'll be here during whole week, including hackathons, so feel free to reach me out in person to talk anything Chainlink related. So let's start with the agenda. In the next 30 minutes, we are going to discuss the Oracle problem and how Chainlink solves it. We are going to have a little code along where we're going to create some simple DeFi app using Chainlink price feeds on Avalanche. And finally, I will have some exciting news for you. So be sure to stay until the end of the presentation. We have some news. Okay, so to understand the Oracle problem, we need to take a couple of steps back to understand the purpose of smart contract. Okay, so we all know what smart contracts are. I won't bother you explaining them, but we really need to understand which problem smart contract solves. And that's the problem of trust. So with the traditional agreements, there's always some third party or so-called contract operator which both parties of the agreements need to trust. So that's the problem, because that third party or contract operator can have some common interest, can have something, you know, in that agreement that it's really for him, right? So it doesn't matter whether you're going to trust the brand, the company, the logo, the paper, some individual, it doesn't matter. With traditional agreements, there's always a need for trust to that third party. And smart contract, or so-called digital agreements, solve that problem because they rely on cryptography and blockchain as underlying technology. So you actually don't need to trust anyone because all of the term sheets are written inside the smart contract itself. They cannot be changed, they cannot be modified, deleted, corrupted in any way. So what's written there stays there forever, right? So you remember that some protocol which banned user to trade game stocks when they need the most? That's not possible with smart contracts. But smart contracts also are not perfect. They have their own problems. They have their own flaws. So one of the biggest problems smart contracts has is that so-called smart contract connectivity problem. So smart contracts live in their own isolated environment, in their own blockchain they're currently deployed, and they cannot access any kind of off-chain data. So smart contract can't know what's the current market price of any given token or coin. Smart contract can't know what's the current weather here in Barcelona. Smart contract can't know who won in the latest El Clasico. Is it Real Madrid? Is it Barca? Smart contract can't know that. And the solution to the Oracle or smart contract connectivity problem is Chainlink protocol. So Chainlink is a decentralized Oracle network consists of independent nodes which serves as a middleware layer for blockchains, no problems, to provide to smart contracts any kind of off-chain data in a trust and a secure manner. So Chainlink is not a blockchain. It's a decentralized Oracle which only needs to reach consensus, and that's it. Anyone can run the node and become a node operator in Chainlink network because everything is open source and free to the community. You can just check it out, and that's it. So, but what happened if you have a centralized Oracle, right? So you're at risk to receive inaccurate data or no data at all. That's why one of the main focuses of Chainlink protocol is decentralization. So Chainlink consists of full replicas run by independent and Sybil-resistant node operators. So the main focus of Chainlink decentralized Oracle network is data validation, consensus, and security. And to answer the main topic of this talk, what are so-called hybrid smart contracts, in one sentence, we can call it like this. So hybrid smart contract is any smart contract which combines both off-chain and on-chain data and computation. And they are really powerful. Okay, so how many of you are going to attend to the hackathon? Is there any hackers here? Oh, quite a lot. So for the purpose of this talk, I wrote a simple smart contract. So this is the simplest DEX ever written. You can see there's only 2 token addresses stored as a storage variables. So this, my DEX, can hold only one pair one liquidity pair, and that's it. So it has add liquidity function to add some initial liquidity to this DEX. It has this swap function to swap a given amount, you see it's a function parameter, to swap from these 2 tokens, and has this view function to get the swap price. It's a simple math function. You multiply the initial amount with the current balance of destination token in the pool, and divide that value with the current balance of from token from that pool. And now imagine that you want to build some DeFi protocol during the hackathon on top of this DEX. Why it's not a good idea to use this get swap price as your source of truth when you want to get like what's the price of token inside this DEX? Can anyone like discuss this with me? Speed? I mean, that's not the main concern here. Yes? Exactly. Yeah, so he's right. This is a vulnerable smart contract. So you can manipulate the price either by adding enormous liquidity to one side of the pool, either by doing in one block, series of, as he said, swaps to actually drain out one side of the pool. And eventually you will have like 1 or 0 as a value as a price, and this is not the correct price. So I deployed this vulnerable contract to the Avalanche Fuji testnet. So if you want to play with it, sure. I added initial liquidity, 10 linked tokens on Avalanche, and 10 wrapped AVAX token on Avalanche Fuji testnet. So this is the initial liquidity to this smart contract. If you were able to drain the funds of 1 token, for example, you can come visit our booth with proof of the transaction. We can give you some extra swag. But what else? Imagine that now you have some a really good decentralized exchange, like which has protections against all of these attacks, it's not vulnerable, etc., etc. Why still isn't a good idea to use any kind of DEX as your source of truth when it comes to the prices? The problem is, never mind, either that's a DEX or a TEX or CeFi protocol or Binance, whatever, like, it's still a centralized solution. It's still the centralized truth of price. So you get the price from only one data provider, whatever the name is. So even if you can't, for example, hack these DEX to change prices in one block, it's still you get price from one single point. And we are in a decentralized world. We want to minimize the single point of failures. That's why Chainlink data feeds comes in. So with Chainlink data feeds, each node can have their own source or sources of truth when it comes to the prices. So imagine this slide. Okay, so I want to ask what's the current price of AVAX token at the moment. So each of these nodes can have their own source or sources of the price. So one of these nodes can use my vulnerable DEX to get the price. But eventually, this decentralized Oracle network needs to reach a consensus to provide the correct price of a token to the calling contract. And nodes have the incentive to do the honest work because they can earn linked tokens. If they do the bad work, they can be punished. To use, in your hackathon, whatever project you want, Chainlink feeds, it's really easy. So you need to go to data.chain.link to find all of the aggregators possible. and then go to docs.chain.link. You will then there find one simple code snippet. So it's really a one function which you can use to get the latest price, and that's it. You can build on top of this. And many notable projects already are using data feeds. Okay, so I said that I will have some exciting news for you, for hackers. That's why I asked you to raise the hand. So we were asked about this a lot during previous 6 months of 1 year from the community members on our Discord, Twitter, GitHub issues, Stack Overflow questions. And finally, I have the opportunity to finally announce that Chainlink VRF V2 is finally available on Avalanche Fuji testnet. So you will have the ability to be the first one to actually try to integrate the new VRF V2 on Avalanche Fuji testnet. This is still in beta, so it's not available on mainnet yet. And there's no that fancy UI for creating subscriptions because it's a beta. But I will now show you how you can do it from your smart contract. So I think you will handle out because you're participating in a hackathon. So before that, to see all of this, which I'm going to show you right now, go to docs.chain.link/AVA Summit without X. docs.chain.link/AVA Summit. On that URL, you will have the ability to see this page. So this is the official docs page just for Avalanche Summit for hackers. So once again, docs.chain.link/AVA Summit. And you will have the step-by-step tutorial how to use VRF V2 on Avalanche Fuji testnet. And that's what we are going to do right now. So if I scroll down a little bit, this is the code. So you can see that inside the constructor is going to create a new subscription. So on, for example, some testnet where the UI is available, you can go to the UI, connect your wallet, and click Create Subscription. We are going to create subscription here. You can create these subscriptions through Ethers.js as well. So it's up to you how you're going to call the smart contract or via Block Explorer, whatever, but you need to create a subscription. After that, you need to fund that subscription, and finally to add some consumer contract. You already deployed smart contract. So I'll just now going to scroll down a little bit. This is all of the parameters you need to know. And if I click here, it's going to open this contract inside the Remix ID. So I'm inside the Remix ID with this contract, and I'm going to deploy it to Avalanche Fuji testnet via injected web provider. Okay, I just need to click confirm and wait for the transaction to be mined. So this is the first step. You need to deploy your smart contract, and it's going to create a subscription. So let's go back to this doc. So after compiling and deploying, you need to fund your smart contract with at least 2 testnet links. So to get testnet links, you need to go to faucets.chain.link, select Avalanche Fuji testnet, connect your wallet, and you will get 10 link tokens. It's free for you. So what I need to do now is to find my MetaMask. I hope you can see this. I need the destination address, right? For funding. Okay, copy address. So small. Link, send. Okay, paste my address here. As I said, 2 link tokens, that's enough. And click next. Finally, I need to sign this transaction, of course. And we need to wait to this transaction to be mined, right? Okay, I think went through. Cool. And finally, what I need to do is to call this top-up subscription function. So this is just for Avalanche testnet because there is no UI. So this top-up subscription, just look at their implementation, is pretty much the same as click add consumer contract in the UI. And that's what I'm going to do now. is going to fund this smart contract with, 2 test links. So this is my balance, top up subscription, click transact. Once again, I need to sign this. Okay, let's wait for the transaction to be mined. Is it mined? Yeah, it is. I think so. Yeah, it is. And finally, I need to call this request random words. So don't be confused by the naming. Words stand for words in computer science, so bitwise words. It's basically going to return uint256 value, random value. So one great power also of VRF V2 is that I can specify how many random numbers random values I want to get as a callback from decentralized Oracle network. With the previous version of VRF, you know that you can only get one random number in one single transaction, and then you need to manipulate, modulo values to get more of this. Now you can specify how much do you want, and you will have the array of random words, which is going to be populated in a fulfill requirement function. So it's so small here, sorry. So finally, I need to call where it is, request random words. And I need to sign this transaction, confirm, and that's it. Right now, I'm waiting this transaction to be mined. I'm waiting a callback from the decentralized Oracle network, so they need to reach out consensus and send me like the random value, and that's it. Okay, so just there's also a helper function inside this contract. Yeah, pending requests. So there's no pending request, it's false. So let's get random values. What's the random number? 0. This is the random value I got as a callback from decentralized Oracle network 1. This is the second. So I got 2 random numbers in a single transaction call. Okay, I will just be here, and we can continue with the slides. So this was the VRF V2 on Avalanche testnet, Avalanche Fuji. But we have even more exciting news for you who's going to participate in a hackathon. Chainlink keepers are also now available on Avalanche Fuji. Starting today, you can use Chainlink keepers on Avalanche Fuji testnet. With Chainlink keepers, it's completely the same experience as is on the other chains. So you need to create a keeper-compatible contract. Keeper-compatible contract means that you need to implement keeper-compatible interface, which consists of only 2 functions. So one is check upkeep, which is oftentimes the view function and returns like true false. So basically on each block or each time frame, depends on the chain, the keepers are going to ask your smart contract, do you need something from me? Do you need some optimization from me? If check upkeeps returns false, nothing happens. If check upkeeps returns true, automatically perform upkeep function is being called. So maybe it's easier with it. So perform upkeep function is being called, and some work is then being initiated by the Chainlink keepers. So with Chainlink keepers, you can watch this slide over here. So if you go to keepers.chain.link website, you will have the ability to switch to Avalanche Fuji testnet. And that's it. Simple as that. So we're not going to demo like keepers because everything's the same. You just need to go to keepers.chain.link and select Avalanche Fuji. Basically the same thing you can find in the docs. And the one last thing before questions, I want to remind you, that the submissions for Chainlink Spring 2022 hackathon are officially open. So this is going to be the biggest Chainlink hackathon so far. You can compete for cash prizes and non-cash prizes. Currently there's like more than 300K in prizes from various sponsors. There will be also an ability for you, if you create some really good project or mini startup, to be invited to a VC pitch demo. And also some of the notable judges will be Sergey Nazarov, Austin Griffith, Patrick Collins, and many more. And whether you're just entering the Web3 space or you think you have what's necessary to win the grand prize, make sure to sign up now at hack.chain.link. For the newcomers, we will have tons of educational content streamed online on our YouTube channel from our developer advocates, from the beginning, like creating a first smart contract, to the more complex topics like creating your own chain DAO or something like that. So where to start from now? You can join either our Discord chat. So this is the link for our Discord to chat with the community members and also with Chainlink employees, Chainlink Labs employees. So you can go to Smart Contract Kit organization on GitHub to find some boilerplate starter kits to build on Avalanche. So we have a starter kit for Truffle, for Hardhat, for Brownie, for Daptals, for Foundry. It's really up to you which one you're going to choose. Basically, there's the code examples how to use Chainlink in your smart contracts and as well how to test them properly. Recently, we also added a fuzz testing to our Brownie and Hardhat starter kit, so make sure to check this out. Obviously, the first step you're going to take when you try to integrate Chainlink is to go to our official documentation, so docs.chain.link. And finally, if you're a beginner, go to Chainlink Academy to sign up for even more educational content. So for ones who is going to participate in a hackathon, again, if you want to use Chainlink, go to docs.chain.link/AVA Summit. You will find all of this URL on this page, which I demonstrated right now. So that will be it. We have 8 minutes for questions. So if anyone has a question, feel free to raise your hand. I will try to answer it to you. Yes? Yeah, so officially there's no limit, but you can get out of gas exception. So that's because you need to populate the storage, and that's a costly operation because S stories takes a lot of gas. And what was the costs? Yeah, so costs are described on the official docs regarding, on which chain you are and stuff like that. So you can switch between chains. There are currently a couple of chains that supports VRF V2, not all of them, but I don't have the information about the timeline, so that's it. Currently, it's on Avalanche testnet. Okay. 2 questions. I see you. You're just.
Are you trying to find a way to give to your network a way to answer to questions that you currently doesn't support?
Yeah, sure. I mean,
something decentralized. So you have not the way to something random that will drain tomorrow in this city.
Okay, so we actually had something. Yeah, so that's called any API. So you can check that on our docs. It's basically a way to create a HTTP GET request from your smart contract. You need to hard code basically the URL you're wanting to reach out. You need to find the proper job on market.link for your purposes. But on testnets it's really easy to try because you can basically copy paste the whole thing from our docs. And I participated in one Chainlink hackathon year ago, and I created a DApp which does some betting on who is going to win the Euro 2020 that was in football. So which country is going to. I needed odds from the markets at that place, so I use any API for that purposes. Yes.
Yeah. So how would you compare Chainlink to UMA protocol? That's a different protocol model.
I'm not an expert in UMA, so I don't know their advantages, disadvantages over Chainlink. But it's basically up to you to try it, to verify it, and that's it. Yes.
Chainlink keepers running for C chains or X chain as well?
I think it's only for C chain, but I will get back to you. It was late notice, yeah. Okay, are we good on time? Any questions? No? Thank you very much.